Hello everyone and welcome back to the Eureka channel. Eureka channel is your go-to hub for mobile application development made simple. So in this video, we'll implement secure transaction in Kotlin using RSA encryption step by step. And by the end of this video, you know how to encrypt sensitive data on the device and safely send them to your backend. Also, you learn key management best practices you must follow in production. So why does this matter? When you build payment application, say for example POS or any other app that handles sensitive data, confidentiality and integrity are mandatory. If card numbers or any personal data, say for example your PIN, travel in a plain text, you are legally and financially exposed. So what RSA does is that it lets you encrypt sensitive data with the server's public key. So only the server can decrypt them with its private key. So two keys, the private key and the public key. The public key is used to encrypt information while the private key is meant to decrypt them, and that happens on the back end. So here's the flow that we're going to follow. So here's the flow, and the first step is that the backend generates an RSA key pair and keep the private key guarded. And the second step will be that the client, and please note, whenever I mention the client in this video, I'm basically talking about the POS. So the client obtains the server's public key, majorly fetched from a secured endpoint. As you can see from my screen, uh, I've, this is the public key that is being returned from a particular endpoint that I have called. So the third step will be that you encrypt the sensitive data like PIN using the public key and base64, which encodes the ciphertext. And the fourth point will be that you send the encrypted payload via retrofit. In my previous video, I have taught you guys how to work with retrofit. And the fifth step, which is the last, is that the server decrypts the private key and process the transaction. We might not bother ourselves so much with this fifth point because all that concerns us is the client, which in our case is the POS. All right, so on the client side, this is the method that helps you convert the text that is coming from your server into a public key. As you can see from the response I got from this endpoint, this is the endpoint that provides the public key. As you can see, the public key, and that's the PEM key. That's the PEM text. So when it gets to your code, so you convert it. As you can see, you need to replace all these begin public key and end public key that comes with it so that we can have a valid public key. Another thing for you to note is to keep the PEM exactly as the server provides it. Keep it exactly as the server provides it. So the next thing you want to do is to write a logic to get the base 64 string that you can safely include in your JSON. And this is what this method is doing. So we get the public key and then it uses that to get the base string from the conversion of your PEM key. So the I'm working with a project that I have done and it's currently live. So I'm not going to be writing a lot of code. I'll just show you what I have done. And then in my previous video, I already explained about MVVM, and that is going to be coming in handy in this video. So if you come to your agent view model class, just like I explained that it is your view model that sits in between your model and your view, your model and your view. So your model makes a call your view model makes a call to the API layer with the help of your model and then returns the results to the view. I've explained that. You can get the video and watch again. So in this view model class, I'm making two calls. One is to get the public key, and the other one is to now put the response of that public key and put it in the method that converts it into a valid public key. So if I seed into this is the method that is calling the get public key from the API layer. So if I seed also into this, you will see this is the get annotation that makes a call to the server to provide a public key. So I'm back in the agent view model. So after that is done, I get hold of the response inside this response variable, and then I use that response to seed into the public key, because it's coming as, if you look at the structure of the backend, it's coming as response.data.public key. So that's the seed to get that public key. So I map into that and I pass it into the get public key string, which is to convert that that key. I believe this is very simple and straightforward. Right. So let me go over that again. Let me go over that again. So I'll just expand. This is where everything begins. If I come into this home fragment, so home fragment is the view that is responsible for this screen that you are seeing right now. So what I have done is, in the on view created of this fragment, I have put my method to fetch the public key, as you can see. So view created just is just like an init state of every other languages. So if you check the fetch public key, so it takes you straight to the agent view model, and the agent view model makes a call to the repository, which I've explained before. And then the repository calls the API level to get the public key. And then when the public key comes back as a response from the backend, we convert it into a valid public key by replacing all this begin public key and end public key with an empty string, and then we decode that using a base 64. So finally, before I move away from the codes, is the last step, which is the most important step, and is the key injection. So on this line 3, you can see I put a comment to inject the key that has been converted. You can see from here, this is the call to the repo, and here this is the conversion. This is the method that is responsible for the conversion. So, and it's being kept in this key variable. So now inject the key into the payment repository, because one thing you want to do is that you want to be able to access this key on every screen where you are going to be making your payment request, because you will need that key. So it needs to be available on every screen, and that's, for example, that's why you will see me printing the key here on the home fragment. And if I take you through every other fragment where the payment is being made, you will see that I'm actually having access to the key. So that's pretty much it about the codes, and I would just like to give some side notes when you are working with encryption and anything that has to do with key. So the first thing you want to pay attention to is that RSA is expensive and only supports small payloads. Now, for larger, I remember while I was working on this project, one of the things I had to battle with was back and forth between myself and the backend developer because the payload is asking me to send is quite large, but however it's using only RSA. So we need to like add a meetup so that we can know how to work around things. So for larger data or many feeds, you want to embrace what is called hybrid encryption. And how you do this is by generating a random AES key on the client, and then you encrypt the data with AES GCM, AES GCM, and then you encrypt the AES key with RSA and then send both. I don't know if you get that. So AES GCM provides confidentiality and authenticity. So I'll link a hybrid example in the video description. Another thing you want to pay attention to is response signing. If you want to ensure the responses are truly coming from the backend, the server can sign the response payload with its private key, and then the client, which is you in this case, can verify the signature with the server's public key. And then you use separate keys for signing and encryption if your security policy requires it. And then finally, you want to handle description failures gracefully. You want to show a user-friendly error, and you don't want to expose your raw exceptions. That is actually also very important. Say for example, there is a network error and you are not able to fetch the public key. You want to display the error gracefully without showing your exception. So important production notes, especially for backend people. So you want to rotate keys periodically, and when rotating, you keep the old keys available to decrypt late arriving messages, or you implement envelope versions. And second point is you want to use a KSM or HSM like I've explained the other time. What I actually used on this project was a KMS, key management system, for my key storage. And then you always ensure to use TLS for transport. TLS is transport layer security. It's only just a protocol, just like the HTTPS and what we have. And then the fourth point is that you don't want to store private keys or sensitive plain text in logs. I think I already mentioned this earlier in the video. You don't want to save it in your client device, and you don't want to display it in your logs. You don't even want to mask it or redact it. And then ensure to use OAEP padding and a random number generator. Also use prefer a standard crypto library like RSA. We have, you can check online, we have quite a number of crypto libraries for encryption. So if you found this useful, you can like the video, subscribe for more Kotlin. I also do Flutter tutorial because this is a mobile development platform, and we teach about everything you need to know about Kotlin and Flutter. So drop a comment if you have any question. I will be more than graceful to help. So thank you guys for watching this, and I will see you in the next one.